Good evening, millennials. Today we'll look at another lead code problem often asked in the intermediate rounds or the final rounds of FAANG interview companies. This is the 402nd problem in the lead code website called remove k digits, and it's a medium problem. So let's read the question and try to find the most efficient approach and write the shortest code possible. So, given string num representing a non-negative integer number and an integer k, return the smallest possible integer after removing k digits from num. Okay, the question seems straightforward, but let's read the examples to get a better understanding. So we are given a number 1432219 as a string, and we are given an integer 3. So we have to remove 3 numbers. So if we remove 4, 3 and 2, the remaining number is 1219, which is the smallest possible. And in the second one, if you see, we have to remove only one number, and if we remove the first one, we get 200, which is the smallest possible. So we have to know that the output must not contain leading zeros. So you mustn't print 0200, but you must print just 200. And if the number is 10 and if you are asked to remove all the digits, you must print 0, and as all the digits have been removed and the number is left with nothing. So the constraints are 1 is less than k, less than or equal to num's length, which is less than or equal to 10 power 5. This means that you can't iterate over num's length over an n square algorithm or use an n square algorithm. And it's given that nums consists of only digits, which is from 0 to 9, and number does not have any leading zeros except for the 0 itself. So the number can be 0, but there's no leading zeros in the input test cases. Okay, so let's try to think of the basic logic. So in this question, we see that to remove the to get the smallest number possible, we need to remove a number such that we need to go from left to right, and we need to remove a number such that its previous digit is less than this digit. So that way we can ensure the smallest number possible, because if we try to remove from the last, you will be ending up with a greater number. So let's try to write a code for this, because the value towards the left is more than the value towards the right. And since we are comparing with the previous elements with the current element of the iteration, we can use a stack, because stack works on the last in first out principle. If you want to know more about LIFO, see our other videos. So we are asked to return the output in a string. So let me just have the output string as an answer, and while doing that we need to make sure we remove the leading zeros. So at last I need to return this answer. So let me just iterate through the number num for auto character num. So while the stack is not empty, so while answer dot size, or you can say, so answer dot size is positive, and answer dot back, if the current element of the iteration is lesser than the character, and we have to remove only k digits. Remember that we have to remove only k digits. So we just check whether k is not 0 or not. So inside the loop we just pop it, and then we reduce k by 1 because we have already removed an character. And else, if the stack exists, or the character is not 0 because we don't want any leading zeros in our answer. So in this case, I just push it to our stack, push it to my stack. And after processing all, assuming we have some k digits left, so we need to remove the possible elements. In that case, while answer.size and k, what do is we just pop it from the back. So let me just write it as k minus minus to check whether k is 0 or not. And at last we have this special condition. When both the digits are removed, we need to return 0 and not an empty string. So if answer.size equal to 0, I just return a 0, else I return an answer. So let me just dry run the code once before running it. So I just iterate through each and every element, and then I add it to the stack if it's not a 0, and if stack size already exists. This case is to check when we get something like 1 0 0. In that case, you need to add that 0 to the stack. And for each element, if the stack size exists and k exists, and if the last element in the stack is actually, it should be greater than the current element. So 1 4 will already be in the stack and it should be greater than the current element. Then we just remove it. So let me just run the code. Yeah, as you can see, we get the answer for this. Let me just try submitting it. I've just submitted it a few times to check for sanity errors, and as you can see, it beats 91% of the solutions, and it's the most shortest solution possible. Probably I can just put it like this so that it seems much shorter. Okay, that's it from our end. And if you can think of a better approach or a better solution or a short clean code, please feel free to write it down in the comments. If you like our videos, please feel free to subscribe. Thank you.